In this video, I'd like to look at a 4-to-1 multiplexer, or MUX. So I am using National Instruments Multisim, and I have built here, I have 6 inputs, 6 switches connected to, and the switch can connect to either high or low. So here in switch A, if I type in A, I'm in the workspace and I hit an A, then the switch goes up and it's connected to this red wire, which is connected to the top of the battery, and therefore 5 volts are a high. If I click type A again, then I'm connected to this black wire, which is connected to the low part of the battery and to the ground, so that is 0 volts. So I'm putting either high or low into A, and that is true for all these inputs. And the first 2 inputs are labeled A and B. And those I'm going to call the select or the address inputs, and they are going to pick out one of the data inputs to get through to the end of the circuit. And then I have these lower ones, these ones that are keyed with a number 0, 1, 2, 3. Those are the data inputs, and I imagine that these data inputs are, so the data can be high or low, so also a switch, and that the data is, each data input is assigned an address. So I have 4 addresses, so they're numbered 0 through 3, and then I need to use 2 bits to identify an address. So 0, 0 will correspond to address 0 and correspond to key 0, and 0, 1 will correspond to a 1, and that's key 1. And so when I put in, you thinking of A as the 2's place in this case and B as the 1's place, I will put in the number, and then the key with that number should get through. So we see here in these AND gates, so the keys are never knotted. They just go straight to the AND gate, to the A's and the B's. I sometimes connect to A and sometimes connect to not A. So A comes here, and that blue line corresponds to the input A. But then I also send it through a NOT, and this orange line corresponds to not A. Same thing for B. This green is B, and this red is not B. So this first AND gate here is sort of, if you will, A prime B prime 0, and the next one A prime B1, the next one AB prime 2, and AB3. So it's all the combinations of A, B, and then with each one, the corresponding data. Okay, so let's turn it on. And right now I am putting in A and B low, which is address 0. So if I hit the 0 key, that when that 0 key switch goes up, we see that the probe lights up at the end. And so that data is getting through. And if I type a 1, no effect, 2, no effect, 3, no effect. So in this case, the 0 data is selected and gets through. Okay, let's now try keep A low and move to B. So that should be now address 1, and the data at address 1 should get through. So type a 0, no effect. Type a 1, that's getting through. 2, no effect. 3, no effect. Okay, so now I will move on to address 2. So switch B and A. So now A is high and B is low. So that is, if A is a 2's place, it's 1, 0, which is 2. So I'm selecting now the data at address 2. So the data at address 0, no effect. 1, no effect. 2, that's causing the blinking. That data is now getting through. And 3, no effect. Okay, the last case is A and B are both 1, that corresponds to 1, 1, that's an address of 3. So the data at key 3, that's what should get through. 0, no effect. 1, no effect. 2, no effect. And 3 is what's getting through. And so that's it. That's the job of a multiplexer. There are inputs that correspond to the address or the select they are going to pick. And then the other inputs are the data. And so you have some sources of data. You're going to use the select or the addresses to pick one of them, and then that is the one that gets through to be the output of the multiplexer. Okay, thanks for your attention.